Hello everyone, welcome back to our class of business statistics. In the previous class, we discussed about computation of median. In this class, we are going to discuss about the computation of mode, which is the third measure of central tendency, and which is actually nothing but identification of the most common values in your data. So, welcome. Let's start. So, what is mode? What comes to your mind when I'm talking about the mode? Where it is actually used. So, mod is something which you are widely using in the standard products industry. Let it be clothing industry, let it be shoes industry, where your purpose is to cater the need of maximum number of people rather than going for customization, right? So, mod is something which is helping you a lot in your business statistics problems. So let's pin down what the mod is all about. The mod is the value that occurs more often in the data set. We already discussed that in the previous class, but let us come to some important properties which are important, which we haven't discussed in the previous lectures. So it is only average that works for categorical data. I mean, you can't take mean of favorite color, but you can find the most common choice of the people for favorite color, the more or most popular favorite color of the people, right? Data is categorical, mean is irrelevant, mode is the appropriate way. So if I ask you which is your favorite subject, and most of the student replied with like say my favorite subject is finance or statistics, then I can take the mode of it rather than I can take the mean of it, right? So one thing is like it is appropriate for categorical data, which was not addressed with which was not addressed by the mean. Second thing, your data can have more than one mode. Your data can be bimodal, unimodal, right? Depending on repetitions of the values in your data set. And like median, it is not affected by the extreme values and outlier. So it is also free from outliers effect, unlike mean, right? So why mode? Why we need to study mode? Because it has a wide applications in the business, right? And when we are studying business statistics, mode is something which has are relevant for our subject area. Or subject area, I mean. Okay, so let's look at these tricky cases with real numbers because speaking is nothing, but we need to learn through practice. We are going to discuss the mode for two type of data, ungrouped data and group data. And as we have discussed earlier also, ungrouped data is a simplest form of data or a raw data, whereas group data is when we have divided the data into different classes based on and based on the frequencies, right? So, what is ungrouped data or group data that we have covered? Once we are done with it, then we need to find out the modes of ungrouped data and group data separately. So, as I've just discussed that we can have more than one mode. We can have one mode in the data set which is called my unimode as seen on your screen. The first graph shows only one range where the frequency is highest. since it is a bar chart, so this might be the data for what? Discrete series. Even if it is a continuous data, then also the bar or a graph uh, showing the highest peak, the bar, the bar with the highest peak is what? Your model range. So this is a model range. In, and there is only one range which is having the highest values. In the second case, there are two bars with the same frequency. So none is actually exceeding the other. So I have two more. One is this and another is this. Two model range. This is called binom model. And in the third case, which is there on your screen, in this case, I have all the values as equal values. All the range have the same frequency. So this is the case of no mode. There is no mode because all values are equal. For, for mode, what I need the higher values or concentration of the values in that particular range. So unimode is like having one mode only, bimodal having two modes, and no mode means all values are equal. So let's look at these tricky cases. Again, the real numbers. So there are examples given here. First, in the first example, some values are given like 2, 3, 3, 5, 5, 7. And I want to find of the mode of it. So what I have to do, I have to find out the frequency. So 3, 1, 3, 2, and then 2 is once, 5 is 2. So I can say the mode is like 3 and 5. So this case is of what? Bimodal, because I have two mode. One mode is 3 and another mode is 5. Next is like I have the values 1, 2, 3, 4, 5. So no value is repeated. So there is no mode. All values are of equal weight. It means this is the case of no mode. In the third case, uh, let us look down 7, 8, 9, 7, 8. So 8 repeated, 7 repeated. So mode is 7 and 8. And 9 is not repeated, so 9 is not my mode. To have the clear picture, let us look at this graph on your table. And this, what you can see that on the x-axis, shoe sizes mentioned, and on the y-axis, frequencies for each shoe size as given. So the size 6 is actually say demanded by one, shoe 7 is demanded by two people, size 8 is demanded by 8 people, then 9 is by 1, 10 by 1. So in this case, I can see the highest, the class with highest size with the highest frequency. So 8 is high in demand, which is having the frequency as high as 3. So this is what my mode. My mode is 8 because it has the highest frequency of 3. So mode is 8. Size 8 is my mode, right? So if I'm estimating the mode of ungrouped data, it is very simple. What I have to do, I have to find out which number is having the highest repetition, highest occurrence. That number become my mode. And if I have two numbers, then it becomes both number become my mode, and this is called the problem of bimodal. And in case all numbers are equal, then I can say it is a no mode data, right? Then moving to the next part in which we will be covering how to deal with the problems of group data for estimation of the mode. This is one example, another example of like ungrouped data. And in this data, what I'm doing. So the here you can see number of count 3, 2, 2. So 2 appears twice, and then I can say 4 appear thrice. 4 is my mode because the number of repetitions are highest for 4. Okay. Now comes to the group data. In the group data, I will create a frequency table, or I'll create a range of the data given, and then I have to take the frequency and cumulative frequency, and thereafter we will be doing the calculation using the formula for mode. With the group data, the individual values are normally hidden. So we start by finding the busiest class. We are looking for the busiest class in which the frequency is highest. The interval with the highest frequency will be my model range, and we can call it a model class, right? And or I can say that it is the class where my mode lives, right? So what but if I want to find out what is the exact value for mode, then we need to interpolate it like we have done in the case of median. And how to interpolate it? We have to use the two neighboring classes for it, right? The larger the gap in the frequency to the neighbor, the more the mode gets pulled that away towards it, right? So what is the formula? And the formula is like mod is equal to so these are the input of my formulas. Like f1 is like frequency of the model class, f0 is frequency of the um, previous class, f2 is frequency of the class succeeding class, and then l lower boundary as in the case of the median, and h is the width of the class as in the case of the median, right? This is the formula. Mod is what? Lower limit f1 minus f0. This is nothing but the difference of what? F1 and minus f0 is like this is current class minus previous class, frequency of the previous class, current class, previous class, and succeeding class in the denominator, and then it has to be multiplied with class width, which is h, right? Then I have to use this formula, and all these ingredients are explained. All these inputs are explained here also, right? So this is what constitute my mode formula. So let us try with the example. So these are the values given in this column. My marks are given, and these are the frequency of the marks. So how many students scored from 0 to 10, 4, 10 to 20, 8, 20 to 30, 12, then 30 to 40, 20, and 40 to 50, 8 and 3. Like, so what I have to do, I have to apply the formula when my formula is like L1. L1 is what? My lower limit of the model class. But how to find the model class? Simply the class in which highest frequency lies. So I'll check the frequency table, and the highest frequency lies in this class, right? So what I can do, I can take like L1 plus frequency of previous class, current class, frequency of previous class upon 2 into F1 minus frequency of the previous class minus frequency of the succeeding class into H, right? So if I go by this formula, what is my F1? So I can say this is my L1, and this is my F1, and this is my F0, this is my F0, and this is my F2. And what is H? The difference between the two. This is 10, my H. Now simply you need to put the values in the formula to get the final answer. So what my final answer is, L1 is like 30 plus F1 is like 20 minus previous class is like 12 upon 2 into 20 minus 12 minus 8 into H, which is 10, right? And then you're solving it. To get the final solution, what you have to do, you have to take like 30 plus 20 minus 12 is 8, divided by 2 into 20 is like 40. 40 minus 12 or 8 is like 20 into 10 into 10, which will give you like 30 plus 8 by 20 into 10, 30 plus 4.25 into 10 is like 4, right? 4 on the 4, 4 5 is 20. Point 2 into 10 is like 4 to the 8, 4 5 is 20, right? So this will give you the 4, and answer is 34, which is your modal value, which is your mode, right? So what is the mode of this exam? The mode is 34. Now, if I come to the graphical findings of the mode or graphical example of the mode, then what I have to do, I have to take the histogram because the data is continuous. So simply what I did with the same question, I have prepared a histogram. In the next example, I prepared the histogram, and histogram is this is my histogram, right? 0 to 10 is 4, and then 10 to 20 is 8, then 20 to 30 is 12, 28 and 3. These are the frequencies, and I've marked the frequencies on the y-axis according to the x-axis, right? And then obviously the mode is what, the highest frequency, which is 20, so which lies in 30 to 40, range of 30 to 40. Then what I have to do, I have to draw a line starting from the corner of what? The previous bar, and it should be touching the corner of what? The current range bar, like this, right? Similarly, I have to draw a line touching the corner of left hand corner of this bar to the corner of the next succeeding bar. And where these two lines intersect is a point where my mode lies. Then what I have to do, I have to drop down a point from this particular point to the x-axis, and the point at which the value at which it touches the x-axis will be my mode. Okay, so in this case it touches somewhere around 34, little less than 35. So 34 is my mode. So I can find out the mode graphically also, and for that what I have to do, I have to prepare a histogram, and I have to identify the mode looking at the high bar with the highest peak, which is actually the highest frequency, and from that I have to like take a line, draw a line uh, from the right hand corner of the model bar. I have to touch the left right corner of the previous class bar. Similarly, I have to take the left corner of my median bar or modern bar, and then I have to touch the left corner of the succeeding bar, and then where these two lines will intersect will be my mode. Okay, so in this way you can find out the mode by dropping down from that point where these two lines are intersecting, and that point I have to find out the value on the x-axis where where that vertical line which I'm dropping from this point is touching the x-axis, right? In this way mode can be find out. Let's practice it, like identifying the model class and then meeting the continuity correction in action, right? So we'll take one more example to have a better clarity. So what is the model class? The model class is the class interval that contains highest frequency, obviously, right? So it is the first and most critical step in estimating the group mode. The first thing which you have to do is what? You have to find out the range with the highest frequency. So if I go for this example, I will find out the highest frequency lies in this range. So this is my model range. And then I have to apply the formula. And what was the formula? L1, which is like 81 in this case, plus F18 minus 12 divided by 2 into 18, frequency of the current class, minus frequency of the previous class, minus frequency of the succeeding class, into I, which is the difference between the two, 5. Okay, and then you can find out the final value. But there is one thing which you need to focus on or be cautious about, and that thing is like there is the gap between the class of I mean class class between the classes. You can say there's a gap between the classes. Here the last value is 80, whereas the beginning value of the next range is 81. So there is a gap of 1. In that case, to bring the continuity in data, what you have to do, you have to find out average, like 80 plus 81. So the last value is 80 and the beginning value of the model class is 81. So I can say I can take the lower limit as 80 plus 81, 161 by 2, which is nothing but 80.5 to bring continuity, right? And thereafter I can apply this formula. So instead of using 80, I can use 80.5 and then recalculate my mode, and you'll get the exact value, right? So how it can be solved? It can be solved like this. Why you have taken 80.5? Obviously, because my data was not in continuity. If it will be like 80 to 90 again here. And why my data is mentioned like this? It is mentioned because the value up to 80 is included in this range, and value from 81 is included, 81 onwards to 85 is included in this range. So if what if the value is like more than 80 and less than 81, and that is why we are taking the average value of this as a lower limit, right? So once you have obtained the lower limit, which is 80.5, then you can find out your F1 is like this, and then F0 is like this, and F2 is like this, and then you can apply the formula, and I is like 5. So my formula will be my mode is equal to L1, which is like 81, 80.5 plus L1 हो गया, okay, frequency which is 18 minus 12 upon 2 into 18 minus 12 minus 7 into 5. And when you're solving it, you'll get 80.5 plus 6 upon 36 minus 12,790 into 5. Solving it further, you'll get 80.5 plus 6 by 17 into 5. And your final answer is the outcome of this calculation, right? Your answer is what? Your answer is 82.25, right? So this is how you go with the solution. So we have already obtained this equation, and once we have these values, my answer is like 80.5, which is my lower limit, and then solving it, I'll get the value 1.765, which will give me the total value of 82.25. So always remember that your approximation value, your interpolated value should be lying in the range of 81 to 85, whereas it should be higher than 81, but it should be lower than 85, or equal to lower than equal to 81, and sorry, higher than equal to 81 and lower than equal to 85. So this is how we go with the calculation of the mode using the grouped data values or range. You can try one more question for a better clarity. So this is the question given to you. Heights are given, and then frequencies are given. But again, looking at this, you'll find that there is a gap between the higher value and the lower level value of the next range. So you have to take L1 again as a average of this 154 plus 155, which is like 9309, right? By 2, which will give you 154.5 for this. But actually, in this case, I'm not supposed to find out the value for this because my mode is there. So I'm more concerned about this class where mode lies. So how to identify this class? Obviously, was simply at looking at the number. The the class which is having the highest frequency will be my model class. So since 14 is the highest number in this column, so I can identify 160 to 164 as my model class. Then I have to find out the lower limit, and to find out the lower limit I have to use this value and this value. So I have to take the instead of taking the average of this, I have to take the average of these two value 159 plus 160 by 2, and this will give me the value of 159.5, which will become my lower limit L1. And then I'm applying the formula. So I have L1 as 159.5, then frequency of the current class is 14, F1, then frequency of the previous class is 9, F0, and then frequency of the succeeding class, then 2 into F1, succeeding class F0, F2, and this is my H, which is the difference between these two, H, so which is 5 in this case, and then I'm solving it. So what I'm doing, 159 plus 5 by 11 into 5 is equal to 161.77 is my estimated modal value. So if I ask you what is a modal height, or at which point most of the students will be height of most of the student will be concentrated, I can say it is near 162 centimeter approximately, right? This is how we go with the estimation or computation of the mode for the group data. So let us have a brief comparison between the two. If I talk about the data form, obviously ungrouped data is individual data, whereas group data is class interval or frequency data. And if I discussed about the approach, obviously in ungrouped data, you need to count the frequencies and you have to find out the most frequent values that will become your mode. But if I talked about the group data, then you need to interpolate the value model class to find out the exact value or estimated value. Whereas your model mode will be lying between the lower range and upper range of the model class. Coming to the formula, there's no need of formula in ungrouped data because you simply have to find out the number with highest repetition that will become your mode. But in the case of group data, you have to use the formula L1 plus F1 minus F0 upon 2 F1 minus F0 minus F2 into H, which we have already tried with the questions. And then coming to the result, this will give you the exact value for, in ungrouped data, and for the group data, you'll get the estimated value. And coming to the graphical tool, obviously the bar chart is fit for ungrouped data, but for the group data, histogram will be more meaningful because the data is in a continuous range. Okay, so let's zoom out to when the mode is the right tool. Three quick checks. Which average work for categorical data? Mode will work, median will work, but mean will not work. So what is the first step for the group mode? Find out the model class and then apply the formula. Why did the grades mode sit low in its class? Or, it bigger preceding neighbors? Because unlike median, because normally in median, succeeding neighbor is always higher in value than the preceding neighbor. Why? Because we were using cumulative frequency there. But in the mode, I'm not using the cumulative frequency. Rather, what I'm using the frequencies, and therefore uh, even the succeeding frequency is lower. Both preceding and succeeding frequencies are lower, and reason is because mode itself means the highest frequency, right? So let's wrap up the central tendency with this. In the central tendency, which is the part of descriptive statistics, we covered about mean, computation of the mean, and we have also categories of mean like harmonic mean, geometric mean, weighted mean, and we have seen the computation of what grouped and ungrouped data. Similarly, we did the same thing with the median, and then we comes to the mode, and we have computed the we have learned how to compute the mode for grouped and ungrouped data. In the next class, we will be looking at the graphical representation of all these three methods of central tendency, and thereafter we will be finding out the comparative difference between the three. So this is all for today. See you in the next class. Thank you.